Now next chapter which we are going to start is that is your mean value theorems. Now first one is that is your mean value theorems. First is Rolle's theorem. So what is the statement of this theorem? Now if a function fx is continuous in the closed interval AB, this is the first point, derivable in the open interval AB, second point, and third point, f of A is equal to f of B, then there exists at least one point C in the open interval AB such that f dash C is equal to 0. That is, there exists at least one point C in the open interval AB such that f dash C equals to 0. Now let us first discuss about all these 3 points. Say this is any function y is equal to fx in the interval x is equal to a and x is equal to b. Now you can see here this is continuous, this is derivable, and this, that is your f of a is equal to f of b. Now what do you mean by it? That when we say that the function is differentiable in this interval, that means at each and every point within this interval function is differentiable, means that tangent exists at every point. When tangent exists between a to b at every point, that means there must be one tangent where the tangent is going to be parallel to the x-axis. That is, there must be at least one point where the tangent is parallel to the x-axis. Now since the slope of the x-axis is 0, so this point is, that is your C point here. Now that is C, f of C is the point here. So at this point f dash C, this must be equal to 0 here. That is, since infinite tangents are possible in the interval a to b, there must be at least one tangent, or there is going to be a tangent where the tangent is parallel to the x-axis. That means slope of the x-axis is 0, therefore slope of the tangent at this point will be equal to 0. Now according to the statement, there exists at least one point. Okay. Now what is the significance of at least one point? Say we have a function like this. So this is x is equal to a, x is equal to b. It is continuous and differentiable in this interval. That means everywhere at every point tangent exists. So you can see that at all these points tangents are parallel to the x-axis, that is, slope of the tangent at these points will be equal to 0. Now we will discuss the application of, that is your Rolle's theorem. So all these 3 conditions should be satisfied simultaneously. If any one of the conditions is not satisfied, then Rolle's theorem will not be applicable. Now for example, the first question is, discuss the applicability of Rolle's theorem for the function fx is equal to mod x on the interval -1 to 1. So we have to discuss the applicability of Rolle's theorem for the function fx is equal to mod x on the interval -1 to 1. Now mod x is continuous over R, that is whole of the real line. You can see here This is the graph of the modulus function here. So it is continuous overall. You can show that at point 0, that is at 0, limit x approaches to 0, negative mod of x is equal to 0. Limit x approaches to 0, positive mod of x, this is 0, and f of 0, that is also equals to 0. So which clearly shows that the function is continuous over the interval minus 1 to 1, closed interval minus 1 to 1. Now for differentiability, at x is equal to 0. Now left hand derivative is equal to limit x approaches to 0, negative fx minus f of 0 upon x minus 0. This is limit x approaches to 0, negative. This is minus x upon x, which is equal to minus 1. Now right hand derivative, this is equal to limit x approaches to 0, positive x over x, which is plus 1. Since these two are not same, which clearly shows that this function is not differentiable at x is equal to 0. Although f of minus 1 is equal to modulus of minus 1 is 1, f of 1 is equal to modulus of 1 is equal to 1. So you can see that two of these three conditions are satisfied, but it is not differentiable, hence Rolle's theorem is not applicable for the function in this interval. For this function in some other interval it can be applicable, but in this interval it is not applicable there. Similarly, say the next question is fx is equal to 3 plus x minus 2 raised to power 2 by 3 on the interval. This is 1, 2, 3 here. Now you can see here in this interval, that is, if I first of all take the derivative here, this is equal to 0 plus d over dx of x minus 2 raised to power 2 by 3, which is your 2 by 3 times x minus 2 raised to power minus 1 by 3. That means it is 2 over 3 into x minus 2 raised to power 1 by 3. At x is equal to 2, f dash 2 is equal to infinity, which means that it is not differentiable at x is equal to 2 here. Now, so you can see here this function is not differentiable, hence straightway we can say that Rolle's theorem is not applicable for this function on this interval. Now let's say the next one is fx is equal to tan x on the interval 0 to pi. Now we know that limit x approaches to pi by 2, negative tan x is equal to positive infinity, and limit x approaches to pi by 2, positive tan x is equal to minus infinity. Very easily you can see that at x is equal to pi by 2, limit of this function does not exist. If the limit does not exist, that means this function is discontinuous at x is equal to pi by 2, which falls in this interval. Hence Rolle's theorem is not applicable for this function this interval, that is your 0 to pi here. Now next is discuss the applicability of Rolle's theorem for the function fx is equal to, what is that? It is x square plus 1 when x belongs to 0 to 1, and this is your 3 minus x when x belongs to 1 to 2. Now in this interval this is a polynomial and hence is continuous and differentiable. In this interval this is once again polynomial is continuous and differentiable. But first is, let me check the limit at x is equal to 1. So limit x approaches to 1, negative x square plus 1 is equal to 1 plus 1, which is 2. Now right hand limit at x is equal to 1 is limit x approaches to 1 positive 3 minus x, that is also 2. And f of 1 is equal to 1 plus 1, that is also 2. So from first, second and 3 implies this function is continuous at x is equal to 1. So and hence is continuous in the interval 0 to 2 here. This function is continuous. Now differentiability at x is equal to 1. Left hand derivative is limit x approaches to 1 negative fx minus f of 1 upon x minus 1. This is limit x approaches to 1 negative, it is x square plus 1 minus, that is your 1 plus 1 upon x minus 1. So this is limit x approaches to 1 negative x square minus 1 over x minus 1, which is 1 negative x plus 1, which is equal to 2 here. So left hand derivative is 2. Right hand derivative is limit x approaches to 1 positive. This is fx minus f of 1 over x minus 1. This is limit x approaches to 1 positive 3 minus x minus 1 plus 1 upon x minus 1. So it is limit x approaches to 1 positive 3 minus 2 is 1 minus x over x minus 1, which is minus 1. You can see from 4 and 5, because left hand derivative is not equal to the right hand derivative at x is equal to 1. So therefore this function is not differentiable within the interval 0 to 2, and hence Rolle's theorem is not applicable for this function in the given interval there. Now next is Rolle's theorem for the function fx is equal to x square minus 5x plus 6 on the interval that is 2 to 3. Now what are the arguments which we are going to satisfy all the three conditions for this function? We will simply say that this function is, first point, being a polynomial is continuous, being a polynomial is differentiable. Straight away we are going to write down these two things. That is, this being a polynomial is continuous in this interval, and being a polynomial is differentiable this function. Now what is f of 2? We can see here it is 4 minus 10 plus 6, it is 0. What is f of 3? It is 9 minus 15 plus 6, that is also 0. So that means all the three conditions of Rolle's theorem are satisfied. So therefore find f dash x, it is 2x minus 5. Find f dash c, it is 2c minus 5. Now according to Rolle's theorem, f dash c is equal to 0. This implies 2c minus 5 equals to 0. This implies c is equal to 5 by 2, which belongs to the open interval, that is 2 to 3 here. So this way we can discuss, we can solve the questions based on your Rolle's theorem. Now next is fx is equal to under root of 4 minus x square on the interval minus 2 to 2 here. Now you can see here in this interval, this function is defined in the interval minus 2 to 2. When it is defined, you can see that it is continuous in the interval, closed interval minus 2 to 2 here. Now y square is equal to 4 minus x square, or x square plus y square is equal to 4. I can show you that it's a circle and it is the upper part of the circle, that is minus 2 to 2 here. Now you can see here this function is continuous in the closed interval minus 2 to 2. Now, and if I take the derivative of this function, you can see that it is 1 over 2 times under root of 4 minus x square into minus 2x. It is minus x over under root of 4 minus x square. So differentiable in the open interval, because this should not be equal to 0, and in the open interval it is differentiable here. So continuous differentiable. Now f of minus 2 is 0, f of 2 is equal to 0. So all the three conditions of Euler's theorem are satisfied. So therefore, from first, f dash c is equal to minus c over under root of 4 minus c square. Now according to Euler's theorem it is equal to 0. This implies c is equal to 0 belongs to the open interval minus 2 to 2. So that is c is equal to 0, which belongs to the interval minus 2 to 2 here. Now next question is, verify Euler's theorem for the function fx is equal to sine square x on the interval 0 is less than equal to x is less than equal to pi. Now sine square x, this being a trigonometric function, is continuous everywhere and is differentiable everywhere. Now what is f of 0? F of 0 is 0, f of pi, that is also 0. That means all the three conditions of Euler's theorem are satisfied. So actually the main thing is you need to write down the proper explanation for the first two conditions, that is continuity and differentiability. Like in this question you will simply say that this being a trigonometric function is differentiable and continuous in its domain. And what is the domain of this? Actually the domain of sine square x is all of the real line, but the given domain is 0 to pi, so it is continuous and differentiable in this interval. Now what is f dash x? It is d over dx of sine square x. It is d over dx of sine x and its square, which is your 2 times sine x into derivative of sine x, which is your cos x, which is your sine 2x here. Now what is f dash c? This will be sine 2c. So according to Euler's theorem, f dash c equals to 0 implies sine 2c equals to 0. This implies 2c is equal to, that is you can say 0 or 180 degree, or this implies c is equal to 0 or pi by 2. But we will not consider 0 because it does not belong to the open interval. So only possible point which belongs to the open interval is, that is your c is equal to pi by 2 here. You have to keep all these things in your mind, that the point c should belong to the open interval 0 to pi. Extreme values cannot be taken into account, so only possibility is that pi by 2 which belongs to the interval 0 to pi here. Now next is fx is equal to x into x plus 3 into e raised to power minus x by 2 on the interval minus 3 to 0. So what is the explanation which we are going to satisfy the first two conditions here? You will say that x into x plus 3 is a polynomial and hence is continuous over the whole of the real line, and exponential function is also continuous and differentiable in its domain. So that is polynomial and exponential functions are always continuous and differentiable in their domains. So this domain is whole of the real line and its domain is also whole of the real line. Now find what is f of minus 3. Is it 0? F of 0, that is also 0. That means all the three conditions of Euler's theorem are satisfied. So what is f dash x? It is x square plus 3x into the derivative of e raised to power minus x by 2 plus e raised to power minus x by 2 into derivative of, that is your x square plus 3x. So it is x square plus 3x into e raised to power minus x by 2 into minus half plus e raised to power minus x by 2 into 2x plus 3. So you take e raised to power minus x by 2 common, minus x into x plus 3 by 2 plus 2x plus 3. So what is f dash c? It is e raised to minus c by 2 into minus c into c plus 3 by 2 plus 2c plus 3. So f dash c is equal to 0. Now but e raised to power minus c by 2 cannot be equal to 0 because exponential is never 0 and is never negative. So this implies that only possibility is that minus c into c plus 3 by 2 plus 2c plus 3 is equal to 0. Minus c square minus 3c plus 4c plus 6 is equal to 0. Minus c square plus c plus 6 is equal to 0. That means c minus 3 into c plus 2 equals to 0. So the two possibilities are 3 or minus 2. 3 does not belong to this interval, so only possibility is that c is equal to minus 2 here, which belongs to the open interval minus 3 to 0. So this way we can solve the questions and relating to that is your Roller's theorem here. We have just discussed that is your Roller's mean value theorem. Now the next one is that is your Lagrange's mean value theorem. So what is the statement of the Lagrange's mean value theorem? That is your, if a function fx is continuous in the closed interval AB, derivable in the open interval AB, then there exists at least one point C in the open interval AB such that f dash C is equal to f of B minus f of A upon B minus A. So this is the statement of the Lagrange's mean value theorem. That is, if a function fx is continuous in the closed interval AB, derivable in the open interval AB, then there exists at least one point C in the open interval AB such that f dash C is equal to f of B minus f of A over B minus A. Now, how we are getting this, you can see here. Let's say this is any function y is equal to fx. Now, in the interval, say it is a to b, you can see here this is continuous as well as differentiable. Differentiable means that in this interval a to b, at each and every point, that is your tangent to this curve exists. Now that means this point is a f of a, and this point is, that is your so it is like this. This point is a f of a, this point is b f of b. Now, so once again, I'm sorry, let me again draw the graph of this, or just to explain you. So this is upon b minus a. So this is your function y is equal to fx in the interval that is a to b. Now this point is, say this point is a f a, and this point is b f of b. Now slope of the chord AB is equal to f of b minus f of a upon, that is your b minus a. Since tangent to this curve at each and every point within the interval AB exists, so there must be a point or points where the slope of the tangent, or you can say that the tangent at this point is parallel to the chord joining these 2 points. Let us say this point is C. So therefore f dash C is equal to f of b minus f of a upon b minus a here. That is, slope of the chord AB is fb minus fa over b minus a. So there must be a point within this interval where the tangent is parallel to the line joining these 2 points. So therefore f dash C is equal to f of b minus f of a upon b minus a here. So this is about your, this is the statement and the explanation for the Lagrange's mean value theorem. Now let us start discussing some applications of Lagrange's mean value theorem. Now first is using Lagrange's mean value theorem, find a point, or using Lagrange's mean value theorem, discuss the applicability of x minus 3 into x minus 6 into x minus 9 on the interval 3 to 5. Now first point, this being a polynomial is continuous as well as differentiable. So that is, the two conditions of Lagrange's mean value theorem are satisfied. Now find the derivative of this. Derivative of this is x minus 3 into x minus 6 into 1 plus x minus 3 into x minus 9 into 1 plus x minus 6 into x minus 9 into 1. So this is by differentiating the product of three functions. So it is x square minus 9x plus 18 plus x square minus 12x plus 27 plus x square minus 15x plus 54. So what is that? This is 3x square minus 36x plus, what is that? 54 plus 18 is 72. 72 plus 27 is 99. So this is the differential of this polynomial function. So f dash c is equal to 3c square minus 36c plus 99 by Lagrange's mean value theorem. F dash c is equal to f of b minus f of a upon b minus a. That is 3c square minus 36c plus 99 is equal to, what is that? It is 2 into minus 1 into minus 4 minus 0 upon 2. So this is equal to 4. So that means 3c square minus 36c plus 95 equals to 0. C is equal to minus b plus minus, what is that? 1296 minus 1140 upon 6. 36 plus minus, this is your 6, 5, 1 upon 6. That is, C comes out to be equal to 36 plus minus. How much is that? Now can I write this as, this is your 3 into 52 upon 6, which is your plus minus of 3 into 4 into 13 upon 6, or it is 36 plus minus 2 root, what is that? 39 upon 6, or it is 6 plus minus 1 over 3 times under root 39. Now, so it is approximately equal to 6 plus minus 1 over 3 into, can I say that it is, what is that? 6.3. Approximately it is 6 plus minus 2.1. Approximately it is equal to 3.9, or it is 8.1. So you can see here 6 minus 1 over 3 into under root of 39. It belongs to the open interval 3 to 5. So which that is your clarifies your Lagrange's mean value theorem. That is, this is the point in the open interval 3 to 5 where the tangent is parallel to the line joining the 2 points. That is your 3 and 5. Now similarly the next one is now using Lagrange's mean value theorem, find a point on the curve y is equal to under root of x minus 2 on the interval, this is your 2 to 3, where the tangent is parallel to the chord joining the endpoints of the curve. We have to find the point on the curve where the tangent, on this interval where the tangent is parallel to the chord joining the endpoints of the curve. Now you can see that this function is defined when for all the values of x greater than or equal to 2. But for this present question, x belongs to 2 to 3. Now, if I find the derivative of this, you can see that it is 1 over 2 times under root of x minus 2. So in the open interval 2 to, that is your 3, this is differentiable and hence is continuous. So it is differentiable as well as it is continuous. Now f dash x is equal to 1 over 2 times under root of x minus 2. F dash c is equal to 1 over 2 times under root of c minus 2. By Lagrange's mean value theorem, f dash c is equal to f of 3 minus f of 2 upon, that is your 3 minus 2 here. So 1 over 2 times under root of c minus 2 is equal to f of 3. Can I say that it is 1? F of 2, it is 0. 3 minus 2, this is equal to 1. This implies that under root of c minus 2 is equal to 1 by 2. This implies c minus 2 is equal to 1 by 4. This implies c is equal to 2 plus 1 by 4, that is your 9 by 4. So c means, question was using Lagrange's mean value theorem, find a point on the curve. Now c is a point on the curve. This implies y is equal to under root of c minus 2. It is 9 by 4 minus 2. It is under root of 1 by 4, which is 1 by 2. So the point on the curve is 9 by 4, 1 by 2, where the tangent is parallel to the chord joining the endpoints of this curve here. So this is the point here. Now next is fx is equal to, this is your x minus 2 sin x on the interval, this is minus pi to pi. Now this being a polynomial and this being a trigonometric function is continuous and differentiable. So what is f dash x? It is 1 minus 2 cos x. F dash c, it is 1 minus 2 cos c. By Lagrange's mean value theorem, f dash c is equal to f of pi minus f of minus pi upon b minus a. Am I right? So 1 minus 2 cos c is equal to f of pi. It is pi minus 0 minus, it is minus pi and minus 0 upon 2 pi. What is that? It is equal to 1 here. So that implies 2 cos c is equal to 0. This implies cos c is equal to 0. This implies c is equal to plus minus 90 degree, because both these points will belong to the interval minus pi to pi here. So these are the points lying on the curve in this interval where the Lagrange's mean value theorem is satisfied. Now similarly, say the next question is fx is equal to 2 sin x plus sin 2x on the interval 0 to pi. Now this being a trigonometric function is continuous and differentiable. So therefore, this is the explanation which you need to give for each and every question relating to Rolle's theorem as well as the Lagrange's mean value theorem. Do not start solving the question by differentiating and using the theorem here. First you need to specify the reasons for which the function is going to be continuous and differentiable. Now f dash x is equal to 2 cos x plus 2 cos 2x. So f dash c is equal to 2 cos c plus 2 cos 2c, or f dash c is equal to f of pi minus f of 0 upon, that is your pi minus 0. So 2 cos c plus 2 cos 2c is equal to, what is that? It is 0 here. Now 2 cos c, or can I say that cos c plus cos 2c equals to 0? So this implies 2 cos square c minus 1 plus cos c equals to 0. 2 cos square c plus cos c minus 1 equals to 0, or this is your minus 1 plus minus, what is that, 3 by 4, which is minus 1 or half. So cos c is equal to half implies c is equal to pi by 3. Cos c is equal to minus 1 implies c is equal to pi, but it does not belong to the open interval 0 to pi. It belongs to the interval 0 to pi. So therefore c is equal to pi by 3 is the point where the tangent is parallel to the line joining the points, that is 0 and pi here. Now next is using Lagrange's mean value theorem, show that sin x is less than x for all x greater than 0. Using Lagrange's mean value theorem, we have to show that sin x is less than x for all x greater than 0. Let fx is equal to sin x minus x for all x belonging to the interval 0 to x here. So this we are considering the function according to the relation which actually we have to prove. So you can consider fx to be x minus sin x or sin x minus x, that is one and the same thing. You can see that this function is continuous as well as differentiable for all the values of x greater than 0. Now therefore Lagrange's mean all the conditions of Lagrange's mean value theorem are satisfied. So f dash c is equal to f dash x is equal to cos x minus 1. F dash c is equal to minus of 1 minus cos c, which is your minus 2 sin square c by 2. Now by Lagrange's mean value theorem, you can see here f dash c is equal to f of x minus f of 0 upon x minus 0. So what is f of x? It is sin x minus x upon x. And what is f dash c? Minus 2 sin square c by 2. Because minus 2 sin square c by 2 is negative, this implies sin x minus x over x is negative. Because x is greater than 0, this implies sin x minus x is negative, which means that I can cross multiply the terms, or this implies that sin x is less than x here. So this way you can prove this inequality using the Lagrange's mean value theorem. Similarly, say the next one is using Lagrange's mean value theorem, we have to prove that b minus a over b is less than log of, that is b over a is less than b minus a by a, where 0 is less than a is less than b here. So once again, let fx is equal to log of x for all x belongs to the interval, that is a to b here. This we are considering because of the result which we require to prove here. Now this being a continuous and differentiable function in the given domain here, where both a and b that is positive here. Now what is the derivative of this? It is 1 over x. What is f dash c? It is 1 over c. Now you can see here by Lagrange's mean value theorem, f dash c is equal to, this is f of b minus f of a upon b minus a. Now what is f dash c? 1 over c is equal to log of b minus log of a upon b minus a. Now as c belongs to the interval open interval ab, that is a is less than c is less than b. So can I write this as 1 over b is less than 1 over c is less than 1 over a. But what is 1 over c? That is your log b minus log of a upon b minus a is less than a. So this way we have been able to prove the required identity or the required result using the Lagrange's mean value theorem. So this is all about that is your Lagrange's mean value theorem. So just we have discussed all these topics, that is your relating to mean value theorem, that is your Euler's theorem and Lagrange's mean value theorem. Again, the importance of these two chapters is there at least for the coming topics of, that is your application of derivative. That's it.